All right, so today we're going to start our new unit that just begins calculus for us, honestly. And in particular, we're going to talk about something called Riemann sums. What Riemann is most noted for is here's this mathematician who noticed that he wanted to be able to find the area underneath curves. And you might wonder why that is. And there's all sorts of applications that we'll discuss more as we get into calculus. But for now, let's just look at this building here. You see this picture of a building with a bunch of windows in it. We want to find the area underneath this curve, maybe in particular to cover it with windows. Well, here you go. We want to find the area of that. And his best way of doing that was to find area of shapes that he now knows. And so if you look here, you can see a bunch of rectangles. So if we could instead find the area of these rectangles and add up all of those areas together, we would have a pretty good approximation. Now, when Riemann did this, the truth is he would do one big rectangle, and you're going to see how I do this. I'll try and use a color that can stand out here. We'll see. So if I was to find the area, and it would be like of this rectangle, and then you would find of the next rectangle, and it would look like that. And then the next rectangle would look like this. And the next rectangle, again, he would just basically find these rectangles. These rectangles. And he would add them up, and it would give him at least an approximation. And what we are going to be doing is an approximation of the area. We will eventually learn how to find the exact value, but that will take us some time, and truthfully, through the end of the school year. So what we're going to be doing is learning, how do I take a curve, such as maybe this curve that I've just drawn here in yellow, and I'm going to find the area of that by simply approximating by area of rectangles. And the hope is, or the recognition is, that the more of these rectangles that we have, the better the approximation is. That's the intention. To do that, we're going to look at a number line. And I know this seems kind of trivial, but truthfully, these are the baby steps to doing Riemann sums. What we will do is we will take an interval, and we need to be able to break it up into missing numbers or little intervals throughout. For example, number 1 here I have goes from 0 to 20, and I want to break this up into 4 subdivisions. You'll see how this links eventually. What we want to do is break this interval up. So we understand that this is 20, and I want to figure out what these numbers would be. So what do you think we would do in order to figure out those numbers? Now, some of you might already know what those numbers are going to be. How did you get there? Because eventually they won't be quite as obvious. My hope is that you can recognize that what you want to do is divide by the number of subdivisions. And so by doing so, this is the number of subdivisions. And what does this 20 represent? Well, that's the length of the interval. So in this case, we got 20 divided by 4, which is 5. That would mean that this first one is 0 plus 5, so that would be 5. Then I would add another 5, that would give me 10. Add another 5, that would give me 15. And if I added another 5, thankfully, I rest nicely at 20. Now let's try another one. Here I've got 0 to 20. Again, I've got 20. I'm dividing it into 1, 2, 3, 4, 5 subdivisions. That makes each one worth, good, 4. So that would mean 0 plus 4, so that's 4. This would be 8, 12, 16, and as expected, 20. All right, maybe one that's not quite so obvious. Here I have 20 still, but I have 3 subdivisions. And it's true. I know it's crazy, but we can have fractions. And so I have 20 thirds. So what does that mean? That the same thing it meant when we were adding 5 or we were adding 4, we're going to add 20 thirds. So 0 plus that would be 20 thirds. Now if you do this well with fractions, honestly, they're already common denominators, so it's not that serious. This is 40 thirds. And the truth is, 20 is 60 thirds, and that is in fact 20, so it works out nicely. Now how that applies is when we look at Riemann sums. Now here we're looking at a very basic shape, a triangle, one in which I hope you can honestly, quickly see, hey, I can do the area of that by doing 1/2 base times height, boom, and I can figure that out, which would be awesome. Okay, so in our own minds, maybe at this point, we're going, yep, 1/2 base times height, 1/2 of 16 times 8, and sure enough, I get 64, easy enough. Great, Mrs. Madison, no problem. I don't need this Riemann stuff. Well, obviously, we're going to be coming up with ones that aren't quite so neat and precise as this. So let's practice on something that is a little bit nicer, and then we'll get to the curve here in a minute. So here I have this triangle, and I want to approximate this area. In order to do that, I'm going to start by just saying I want to do 2 subdivisions. Now, if I'm going to do 2 subdivisions, that means I'm taking the length of the interval, and I'm going to divide it in half, or divide it into 2, right? So I need to figure out where that missing number is. And so 0 to 16, right? So I have 16. I'm just going to kind of do a little circle here. So I got 16 divided by 2. That means each one is worth 8. So I get this is 8, and that's 16. No big deal. Now we are going to learn specifically today, and honestly throughout this course for pre-calculus, right-hand Riemann sum. When we get into calculus, we honestly will learn left hand, midpoint, and trapezoid. But for today and throughout the rest of the school year, we're only going to work on right-hand Riemann sum. Well, what exactly does that mean, right-hand Riemann? Well, right-hand Riemann basically means that you will take the height of your rectangle from the right-hand side of the interval. So let me point out what I'm saying. Here I have this block right here, 0 to 8. And the height of my first bar or rectangle is going to be found from the right point, here 8, up to where it meets that graph, and that's where my height is going to be found. Again, the next bar then is going to be determined by going to the right-hand side here, so at 16, and its height is determined at, what's the height at 16? In this case, that's pretty easy because that's 0. So here I have 0 as that height. So the area of this box, that first one and the one in green here, is 0. The area of the box in pink here, or rose, or whatever you want to call it, would be 8, and the height is whatever this height is of that box. Now, to figure that out, truth be told, you would need to know the equation of this. I think it's pretty obvious because we're dealing with a triangle, and we can see pretty easily that the slope is -1/2 or 1/2, and we can tell that, oh, yep, that's sure enough, that's hitting it at 4. So the height here would be 8 times 4 is 32. So my approximation for 2 subdivisions would literally be 8 times 4, which is 32. So what if instead I wanted to do 4 subdivisions? So I'm going to erase all this ink here, and I'm going to figure out 4 subdivisions. With 4 subdivisions, that means that I'm breaking up this interval into 4 spots. Okay? So I have 16 divided by 4. That means each one's worth 4. So I have 4, 8, 12, 16. My first bar is going to be calculated from the height at whatever it is at 4. The second one will be at 8. The third will be at 12. And the last will be this one at 16. Well, we already know this 8. And we already know the 16 because we've already done those, but we'll do it again here in just a moment just to point this out. So let's just point out that the width of every one of these bars is now 4. And I like to write it like this. Every single one of these is going to be 4 times the height, 4 times the height, 4 times the height, 4, well, there's no height there, but times the height. So there's 4 subdivisions, so I'm going to have 4 heights. This is how I'll write it every single time. So the 4 is right from here, and each of those are going to be the height. This in particular is what is the height at 4, what is the height at 8, what is the height at 12, and what is the height at 16. Again, I already know that one, and I already know f of 8. So f of 4, I'm just going to help us out, is 6. And so and then the next one, of course, is 2. So I would figure out that's 12 times 4, 48 is my next. Now, what happened when I increased the number of subdivisions? If you remember over here on the side, I already erased it here, but we had figured out that the exact area was 64. And so what did that tell me? I'm getting better. I'm getting closer. And if you think about it, the gaps here aren't nearly as much. So the error is less. Now, what if we have a curve with something like this? The process doesn't change. Again, you're going to see it even on the homework packet that I'm going to ask you to do, 2 subdivisions or 6 subdivisions or whatever. I want you to be able to do the same idea. We're going to start with 2 subdivisions. And with 2 subdivisions, that means that I'm going to break this thing up ever so nicely into 2 subdivisions. So how long is this interval? Well, it's 6. I'm going to keep it in that circle. I'm divide it by 2. That means they're each worth 3. So I'm going to take -2 plus 3, and sure enough, it falls at 1. And then 1 plus 3 was 4. So my first bar is going to be at 1. And my next one will be at what the height is, F4. So what is the width of each of my bars? 3. And I need 2 heights because it's 2 subdivisions, 2 heights. And the heights are taken from the right-hand side of the interval, so it's f of 1 and at f of 4. How would I figure out the height at 1? Well, the nice part is it's giving me the equation. And so if I want to figure out what it is at 1, then that means this height is going to be y equals 25 minus 1 squared. And so that would be 24. And f of 4 is going to be 25 minus 4 squared, or 25 minus 16. And so that would be 9. And so I would have 3 times 33. I get 99. What if instead I said 6 subdivisions? So my length hasn't changed. I divide by the number of subdivisions. I would have 1 would be each one. So as I clear this out, that means that my next one's going to be at -1, then at 0, then at 1, then at 2, and then at 3. Sorry, I didn't get my ruler out, but hopefully that's close enough for you. You can see that these are even. What's the width of every bar? Yup, you guessed it. It's 1. And how many blanks should I have? Hopefully, you all said 6. All right, so now I've got 6. Where's the first one taken at? The first one is at f of -1. The next one is at 0. The next one would be a +1. And then at +2, +3, and +4. Now, if you want, you might want to pause the video at this time. And I'm just going to quickly calculate each of these and put them in the blanks for you. So pause the video if you want and do it yourself. And then check back here in just a second and you'll see the answers revealed. And as promised, there they are. There's all your answers. So 24, 25, 24, 21, 16, and 9. Because I'm going to add all this up together. Since I don't have a calculator still, because you won't, that's 25. Oh, right there, 24 and 21 make 45. I've got another 25 here. I've got 24. So that's 50, 95, and 95 plus 24, is that 119? Times 1, right? So it's 119. And it seems to me that I definitely have a little bit less error. So once again, I must be getting closer to the answer. Well, hopefully as you look at this example, you can follow along as you look at your homework assignment. You'll notice that the homework question starts with 1 subdivisions, 2 subdivisions, 4 subdivisions, and 8 subdivisions. Again, it doesn't give you the equation, but what you can do is you can use a ruler or some kind of straight edge and measure it up and look over at the y-axis to see what the height actually is right along that graph. Can be a little tricky. Sometimes I use the corner of a paper so that I can see it kind of line right up and find the y value at each of those points. So your job, honestly, is to do number 1 and number 2 in the homework packet. You'll see then in number 3 is kind of how you fill in the missing number lines. And number 4 in the homework is really getting used to summations because truth be told, they're all going to come together. And you'll see how summations kind of dovetail with this whole thing. We will be practicing this more on Friday. So for any of you that will be absent on Friday because of the vacation, just know that we'll be practicing it some more. And when you come back from vacation, we're going to hit the ground running with those sigma things. So, all right, good luck and do a good job on that homework.